Good day everyone. Welcome to the video lesson on operating systems. Myself, Mrs.V.Vanthana, Assistant Professor, Department of Computer Applications, SFR College for Women. Today we are going to discuss about the topic process, states and its life cycle. First we are going to see the learning objectives for the topic. First we are going to learn about the process and its characteristics. Next I am going to explain the different states of process. Then we are going to analyze the life cycle of process. And lastly we are going to study the difference between the process and the program. So first, what is but a program which is in its execution stage. So as it is in execution stage, process can be defined as an active entity. Process is used to perform a particular task in the system. It will be managed by the operating system, that is for all the utilization, CPU team assignment and then memory allocation, all will be done by the operating system. So the process can be managed by the operating system. When is loaded into the memory and started its running procedure, then we can call the program as a process. Example for the process are, if you are running a web browser means then it can be a process. If you are opening a Word document or PowerPoint means it will be a process. Or else if you are executing a Python script, JavaScript or anything else means it may be a process. So then we are going to see the key characteristics of a process. So first characteristics is, as I already said, process is an active execution, that is a program in the execution stage. Then the process contains resources such as CPU time, memory needed to execute the process and then I/O devices. Then each process contains a unique process ID. It will be assigned by the operating system. That process ID will be utilized by the OS to individually identify it in any instances. Then OS will describe the process by using a data structure called PCB. PCB means process control block. This data structure contains all the basic information about the process, such as process ID, program counter which contains the address of the next instruction, and then process state, and then starting line, ending line, and then etc. Then OS will describe the process using a PCB. PCB is nothing but a data structure used by the operating system to manage the process. PCB means process control block. This data structure contains all the basic information about the process, like process ID, program counter which contains the address of the next instruction, and then process current state, then priority of the process, and then the general purpose registers utilized by the process for execution, and then the list of open files, list of open devices, and lastly the protection mechanisms. Then we are going to see about the components of a process. So regarding the components, there exist 4 components for a process. The first one is stack. The process utilizes stack to store the basic temporal informations like method data or function parameters or the return addresses of the functions or the local variables utilized by the process. Then comes the heap. So we all know that heap is a data structure. So the process utilizes the heap data structure for the memory. Whenever a process needs the memory, that will be allocated dynamically from the heap data structure by the operating system. And then comes the text. So here in the text section, it contains the actual instructions that the process has to executed by the CPU. Then comes the data section. So here the data section contains all the global as well as the static variables utilized by the process for execution. Then we are going to discuss about the process states. There exist 5 states for a process. The first initial state of a process is new state. So whenever a process is being created, then it will be in the new state. In this state, all the memory allocation and the initialization process will be performed. And then comes the ready state. So whenever a process is loaded into the memory and it is waiting for the CPU time, then it will be in the ready state. So if the process in the ready state means it will be ready to execute but not currently running. So it is waiting for the CPU allocation. Here there exists a queue named ready queue So all the process waiting for the CPU time will be in the ready queue, and then it will be dispatched to the next state according to the first in first out mechanism. So next comes the running state. So whenever a process got the CPU time and got the processor for execution, then the process will be in the running state. So the process is being executed on the CPU means the process will be in the running state. So at a time only one process can be in this stage. So at a time only one process can be run by the processor. Next comes the waiting state. The other name for the waiting state is blocked state. So whenever a process achieves some interrupts or it needs some IO devices means, then the process will be in the waiting state. So that is called as some event, whether it may be waiting for the IO devices or it may acquire some interrupts from the operating system. So in that case the process cannot proceed further until that event is properly handled. So that state is called as waiting or blocked state. Then finally comes the terminated state. The other name for the terminated state is exit. Whenever the process has completed its execution, then that state is called as terminated state. After that the process will be killed by the OS and will be removed permanently from the system. So next we are going to discuss about the life cycle of process. As I already discussed, there exists 5 states for a process: new, ready, running, waiting and then exit. Whenever a process is created, it will be in the new state. If it is ready to execute then it will be sent to the ready state. From the ready state, the scheduler will dispatch the process to the running state. If the process is currently executing means, it will be in the running state. If the process acquire any interrupt means, then it will send back to the ready state. If it needs any IO devices or any further request means, it will be sent to the waiting state. So from the waiting state or else from the ready state, the process will send repeatedly to the running state until it finishes its execution. So if it finishes its execution means, then it will be sent to the exit state, that is termination state. After that, it means that the process completed its execution successfully. So let's discuss it deeply with an illustration video. So consider a process green. It is created. From the new state, it is admitted to the ready queue. So here from the ready queue, the scheduler dispatched that process to the running state. So here it is running, the green process is currently running, and then the red process arrived, it is joined to the ready queue. So here the green process acquires some interrupt, so it will be thrown back to the ready state. Here in the ready state there exists 2 processes. So here red process receives its signal and then it will be sent to the running state. Currently CPU is running the red process. So here a new process arrived, yellow process, it joined to the ready queue along with the green color process. Now the red process needs some IO devices to continue its execution, so it is sent back to the waiting state. It is waiting in the waiting queue, it is waiting for the IO. So in the intermediate time, the green process got the CPU to execution, it is continue its execution. So red process is waiting, so it got its IO, so it is sending back to ready queue. So now 2 processes in the ready state and 1 green process in the running state. So green process successfully finished execution, so it is sent to the termination state. Now yellow process got the CPU for execution, so it is going to run, it is currently in the running state. After execution, it will be sent to the termination state. So it is illustrated clearly, and then comes the remaining 1 process, red process. Here it got the CPU time, it is sending to the, it is currently in the running state, it is doing its execution. So after its execution, it is sent to the termination state. So like this, the process will continue its execution until it reaches the termination state. Next, we are going to discuss the difference between the process and a program. Program means we all know that it is a set of instructions written by the user using some programming languages like C, C++, etc. So it is called as passive entity. On the opposite end, process is an active entity. Here program means it is in the static, That is, it does not change its states. But process is dynamic. It can change its states during execution. So we arrived to the final session. As in conclusion, I conclude that a process represents a running instance of a program. It can transit through various states like new, ready, running, waiting and termination during its execution. So these transitions will be overall managed by the operating system to ensure that whether the process contains efficient CPU usage for the smooth execution of multiple processes concurrently. Thank you.